Hi, I'm Sliwka. This is for Team 9. We're doing an aluminum air battery experiment. The objective of our experiment was to create an efficient aluminum air battery out of household items, and we also wanted to test the longevity of the battery. So here is our aluminum air battery. It was made out of household items to power a small DC motor. So the target potential for our battery was to be around 0.7 volts, and we also tested the efficiency of the battery, and we also saw the effects of compression onto the battery. So the theory behind it is that an aluminum air battery works off oxidation. It occurs at the aluminum anode, and reduction of oxygen occurs at the cathode, and together it forms a galvanic cell. In this process, aluminum is consumed to produce aluminum hydroxide. Since the reactants are from the air, we expect the aluminum air battery to have very high energy density. So the equations of the cell and the overall reactions are found right here. So the anode side is given right here. We have the cathode side, and the overall reaction is given right here. The efficiency of the battery was calculated with the following equation. We find that the efficiency eta is found from the experimental value divided by the theoretical value times 100. Some materials that we used in our experiment were aluminum. The aluminum was cut from an aluminum tray. We used common table salt. We also used water, paper towels. We use activated charcoal found in aquariums. We use a digital multimeter to read the voltage of the battery. Jumper wires were used. We used electrical tape to connect the jumper wires to the aluminum. Hammer was used to crush the activated charcoal. A DC motor. We used a stirring rod, a cup, plastic bag to combine a plastic bag, and alligator clips.
Go. All right. So for our procedure, we took the aluminum tray, cut out a square, then we took the copper wire or the jumper wires, laid them down onto the aluminum and taped them down. Then we mixed the salt and water into a cup, stirred it up to try to get it as diluted as possible with it. Then we took the paper towel down and poured the salt water over the top of the towel to soak it as much as possible. We wanted to get as much water into the towel as possible. Then we took the charcoal, we put it in a plastic bag, and we used the hammer to try to ground it down into as fine particles as possible. Then after destroying the particles with the hammer, we poured that onto the wet paper towel. Then we took another jumper wire and placed it in the activated charcoal. And then we added more salt water solution into the charcoal. Then we fold it over, place that paper towel onto the aluminum, and added more salt water solution over the top. Then we folded the aluminum over the top, compressed it down as much as possible. We folded in all edges to seal off the fuel cell. Then to compress it even farther, we rolled it with a roller, trying to compress all the air out. Then we connected the fuel cell up to a multimeter and to show our voltage, and then to try and increase our voltage, we added weight and compression to the top of the fuel cell. All right. So for our results, when we did the voltage originally with it uncompressed, we got about 180 millivolts as our maximum reading. That gave us 25% efficiency. When we added weight to the top of the fuel cell battery, we were able to increase it all the way up to 0.591 volts or 591 millivolts, increasing our efficiency all the way up to 84%. We hooked it up to the DC motor, but we were unable to get the DC motor to run. This is because the DC motor had a voltage range of 3.3 to 5 volts, so we were not able to see any movement out of the DC motor. The voltage was tested 2 hours after the experiment. Due to the amount of salt water we put on top of put in the battery, it was able to stay wet, and we were still able to get a compressed voltage of 450 millivolts out of the fuel cell. So some sources of errors that we had, we were getting some different values during our experiment when I would touch the multimeter to the copper wire or jumper wires versus when I would take one and place it directly onto the aluminum, and the other one was touching the charcoal jumper wire. Because of that, we weren't able to see as accurate of values. I believe this is due to the jumper wires. Next time it would be more likely a better solution to use copper wiring. The granular charcoal was very hard to crush into a powder with just the hammer, and due to that it provided less surface area for the reaction. We were unable to get it into a finer powder to make the active area greater and increase our voltage. The DC motor was also too strong, so our 0.7 volts battery would never have even been able to move the DC motor, and we didn't realize this until after we looked up the DC motor after the experiment was over. Alright, so following steps to improve this experiment if it was to be ran again. We would get a mortar and pestle to really grind the grains down into a fine powder and place that onto the paper towel instead of using the grains that were just broken up using a hammer. We would super saturate the water solution by heating up the water to almost to a boiling point and then adding salt water and mixing it so that it would be a higher concentration of salt in the water. We would also use a LED light bulb instead of a DC motor. This would show us voltages at a much lower range, and it was also be able to show us, due to the brightness, the actual amount of voltage we were getting. And then we would hook up multiple fuel cells in parallel to try and get a higher voltage, and then maybe with multiple fuel cells in parallel we would be able to run a DC motor off of. Alright, so in conclusion, when the fuel cell was compressed, we did find that it was able to increase the efficiency from 25% all the way up to 85%. And then also, the fuel cell was able to hold a charge much longer because it was stayed wet with the saltwater solution. The reaction was able to take place and recorded voltages up to 2 hours after with still a decent amount of efficiency. Thank you for watching our video.